Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A CEO just opened a ticket that reads, "My endpoint is not responding." They stare at the screen like it's written in Klingon. Endpoint? They're not alone. Walk into any first IT job and half the words will be new. Last video, we broke down IT career paths and salaries. This time, we're pulling back the curtain on the jargon so you can walk into that office already speaking the language. By the time we're done, you'll have 3 practical superpowers. 1. You'll decode the top 10 acronyms that get thrown around in IT meetings. 2. You'll be able to explain a server, an endpoint, and an IP address, no searching required. 3. You'll know exactly how multi-factor authentication and single sign-on differ, and why calling one the other can get you locked out of your own accounts. Let's build that vocabulary. When your laptop breaks or you can't log in, you don't wander the office looking for the IT person. You contact the help desk, the frontline team dedicated to fixing internal tech problems. And you don't just send an email, you submit a ticket. A ticket is a tracked, prioritized work item that ensures your issue doesn't vanish into someone's overflowing inbox. The flow is simple. An employee reports a problem, a ticket is created, it routes to the help desk, and they work it until there's a resolution. This diagram is the entire rhythm of IT support. A ticket is much more than a message asking for help. It follows a structured life cycle that allows IT teams to organize work and measure service quality. The ticket is created when the user reports an issue. Next comes triage, where the help desk determines how serious the problem is, how many people are affected, and who should work on it. Many organizations use a service level agreement, or SLA, to define how quickly different types of requests should receive a response. For example, a password reset for one employee may have a different response target than an outage affecting an entire department. After the issue is resolved, many organizations send a customer satisfaction, or CSAT, survey to gather feedback. Every step is recorded so IT teams can identify recurring problems, improve service, and plan future improvements. When you call the IT person's cell, you might get help faster. That's the temptation. But that single call leaves no trace, no data to find patterns, and no way to prove you asked. Submitting a ticket through the help desk portal creates an audit trail that lets IT spot recurring issues before they take down the whole company. The ticket also comes with an SLA that guarantees a response time, so your request doesn't sit in limbo. In IT, if it isn't in the ticket system, it didn't happen. Let's check your understanding. Which statement best describes the purpose of an IT ticket? A. It replaces email completely. B. It tracks, prioritizes, and documents technical work from beginning to resolution. C. It automatically fixes technical problems. The correct answer is B. Tickets help IT teams organize work, measure response times, assign ownership, and maintain a record of what happened. A sales manager jumps out of a taxi at the airport and 3 blocks later realizes the company laptop is still in the back seat. Panic sets in. That machine has customer contracts and financial reports. But before the taxi even reaches the next intersection, IT has remotely wiped every byte of data. No leaked docs, no compliance nightmare. This is exactly the problem that endpoints and mobile device management exist to solve. Mobile device management, or MDM, allows IT administrators to manage and secure company devices from a central console. Each managed device regularly communicates with the MDM platform to receive security policies, software updates, compliance checks, and management commands. If a company laptop is lost or stolen, IT may be able to remotely lock the device or erase company data, depending on the organization's security policies. MDM also helps enforce encryption, screen lock requirements, application management, and operating system updates. Without centralized management, protecting large numbers of laptops, tablets, and smartphones becomes much more difficult. A common beginner mistake is thinking endpoints are only laptops. An endpoint is any device that connects to your network: smartphones, tablets, printers, even IoT sensors on the factory floor. IT must secure every single one because each is a potential doorway into the company. That printer in the corner? It's running a tiny web server and probably hadn't been patched in 2 years. When you hear endpoint, picture a whole fleet of devices, not just the one in your bag. Quick review. Which of the following is considered an endpoint? A. A laptop. B. A smartphone. C. A network printer. D. All of the above. The correct answer is D. An endpoint is any device that connects to a network and must be managed and secured. The terminology you're learning today appears everywhere in IT. You'll hear these terms during help desk calls, project meetings, documentation, cloud deployments, security discussions, certification exams, and technical interviews. When you already understand the language, you spend less time translating unfamiliar words and more time solving real problems. Learning the vocabulary of IT builds confidence, improves communication, and makes every future technical topic easier to understand. Let me paint a real scenario. A marketing director's personal Gmail gets caught in a data dump. She used the same password for her work account. A hacker in Belarus notices, and at 3 a.m. they try logging into her company email. But this time, the login triggers a push to her Authenticator app, a 6-digit code they can't intercept. Account locked, breach prevented. That is the reason multi-factor authentication exists. Passwords alone aren't enough anymore. Here's how it actually works. You open an app like Duo or Google Authenticator on your phone. At the top of the screen, you see a 6-digit code. It refreshes every 30 seconds. You type that code into your laptop's login screen, right along with your password. That code proves you have something physical, your phone, not just something you know. If a hacker in another country tries to sign in, they'll never see that one-time code. But here's the part almost everyone gets wrong. Not all MFA is created equal. SMS codes, those text messages with a login number, are significantly weaker than authenticator apps. Why? Because of SIM swap attacks. A fraudster calls your mobile carrier, pretends to be you, and convinces them to port your phone number to a SIM card they control. From that moment, every login code sent via text lands right in their inbox. They bypass the second factor completely. Instead, rely on a rotating code authenticator app or a hardware security key, something the SIM card attack cannot touch. Quick checkpoint. Your help desk is setting up MFA for a new hire. Which second factor is stronger? A text message with a code, or a code generated by an authenticator app on their phone? And why? The authenticator app is stronger. Monday morning, Sarah walks into a growing startup, taps her fingerprint on her laptop, and logs in once. That's it. Her email is open. Slack is ready. Jira has her sprint board. Salesforce shows her pipeline. She never typed a single app-specific password. That's single sign-on. One identity, issued by a central provider, unlocks a dozen cloud applications. Not one password for each. One identity to rule them all. Here's what happens behind the scenes. You open an application. Instead of asking directly for your password, the application redirects you to a trusted identity provider such as Microsoft Entra ID or Okta. After you successfully complete your sign-in and any required multi-factor authentication, the identity provider creates a secure authentication token. Protocols such as SAML and OpenID Connect are commonly used to exchange this information securely. The application validates the token and grants access without storing your password. Your password remains with the identity provider rather than being shared with every application you use. A mistake I see new hires make all the time: they confuse single sign-on with a password manager. They aren't just different tools, they solve entirely different problems. SSO eliminates the need for separate passwords by issuing a trust token. A password manager just remembers all those separate passwords and fills them in. A password manager will auto-type Slack password 3 into Slack. SSO means Slack never had its own password at all. If you expect a password manager to work like SSO, you'll be confused when you're asked to log into your identity provider manually every morning. True or false? If your company uses single sign-on, you don't need MFA because SSO is already secure. That's false. SSO is just the gatekeeper. MFA is what makes the gatekeeper verify you're actually you. Even with SSO, a stolen password can still get someone inside, unless there's a second factor standing guard. Imagine a retailer Gadget Zone on Black Friday. At 6:02 a.m., their website goes dark. Not a bug, the entire site is unreachable. Their single server, a powerful machine in a back-office closet, had been humming along serving a few hundred visitors a day. That morning, 15,000 people hit it in minutes. The server choked. No orders, no checkout, just an error page. A server, at its core, is a computer that processes requests and delivers data to other devices. But when one goes down, every service tied to it goes dark. In the next scene, we'll break down exactly how a client talks to a server, and why today, almost all of them live virtually in the cloud. Every time you open a website, your browser acts as the client. It sends an HTTP or HTTPS request across the network to a web server. The server processes the request. It may retrieve information from a database, perform calculations, or generate dynamic content. Finally, the server sends an HTTP response back to your browser. Your browser displays the result. This request and response process happens every time you click a link, refresh a page, submit a form, or search for information online. If the only server you've ever seen is the one physically bolted under a desk, that's a physical server, a real machine in a rack. But that approach got expensive fast. Today, a hypervisor carves one physical server into multiple isolated virtual machines, each with its own OS and apps. Cloud servers take that same concept and rent you a VM by the hour on someone else's hardware. The hardware is invisible. You never even touch the rack. Most servers you interact with are virtual, running on shared physical infrastructure you'll never see. Let's review. What software allows one physical server to run multiple independent virtual machines? A. Microsoft Word. B. A hypervisor. C. A web browser. The correct answer is B. A hypervisor divides physical hardware into multiple virtual machines, allowing organizations to improve hardware utilization and simplify management. Picture this. A network printer and your coworker's laptop both claim the same IP address, 192.168.1.50. Suddenly, print jobs land on the wrong machine, the printer vanishes from the network, and nobody can connect. An IP address is like a postal address for devices. Every machine needs a unique number, so data goes to the right mailbox. When two devices steal the same address, packets get routed to the wrong recipient, or not at all. Duplicate IPs are one of the fastest ways to cause chaos on a network, and IT will spend the next hour hunting down the imposter. Let's perform a quick hands-on exercise. If you're using Windows, open Command Prompt or PowerShell and type ipconfig. If you're using Linux, type ipadder. If you're using Mac OS, type ifconfig. Look for your IPv4 address. You may see an address such as 192.168.1.12 or 10.0.0.25. These are private IP addresses used inside local networks. We'll learn more about public and private addressing in the next section. Here's the mistake almost every beginner makes. You open ipconfig, see 192.168.1.25, and assume that's what the website sees. It's not. Your router runs something called N8, Network Address Translation. It takes all outgoing traffic from every device inside your home, strips away your private 192.168 address, and stamps the packet with a single public IP. Every device in your house shares that same public address. The internet never sees your private IP, which is why getting your private IP from a YouTube video is useless to an attacker. They need the public one. Quick review. Which statement is correct? A. Every device on the internet uses the same IP address. B. Private IP addresses are normally used inside local networks and are translated before reaching the public internet. C. Public websites can directly see your private IP address. The correct answer is B. Your router performs network address translation, or N8, allowing many private devices to share one public IP address when communicating with the internet. Run this terminal command on any Linux or Mac, and you'll see something startling. The letter A, the first character of the alphabet, is stored inside your computer as a pattern of 8 ones and zeros. 01, /, cell 1. Each individual 1 or 0 is a bit, the smallest unit of data. Every photo, every video, every spreadsheet is ultimately an enormous string of these bits. The computer doesn't see the letter A. It only processes patterns of voltage, high for 1, low for 0. Here's the trap. Your internet provider sells you a 100 meg connection. That's 100 megabits per second, not megabytes. 8 bits make 1 byte, so divide by 8. Your maximum download speed is about 12.5 megabytes per second. If you expect a 100 megabyte file to download in 1 second, you'll be disappointed for 8 seconds. Always check the B's. Lowercase b means bits. Uppercase B means bytes. Misreading that single letter is the reason people overpay for faster plans they don't understand. Final checkpoint. Your internet connection is advertised as 100 megabits per second. Approximately how many megabytes per second can you download under ideal conditions? The answer is about 12.5 megabytes per second. Remember, 8 bits equal 1 byte. Whenever you compare internet speeds and file sizes, always check whether the measurement uses bits or bytes. You walked in with that deer in headlights look every new IT hire knows. Now you can decode a ticket lifecycle from triage to CS8. You can tell MFA and SSO apart, and, more importantly, when to use which without locking yourself out of your own account. And you can open a terminal, find an IP address in 10 seconds, explain what a server actually does, and never fall for the 100 megabits means 100 megabytes speed trap again. 3 badges you didn't have 20 minutes ago. Frame them on your brain. Now let's talk about what makes a computer physically tick. Next up, in the IT Fundamentals Masterclass, 3 layers every machine runs on: hardware, software, and firmware. Ever hit the power button and wonder what happens before Windows or Mac OS even loads? That's firmware waking up the hardware. Part 7 pulls back the curtain on the physical layer, the operating system, and the sneaky middleman that ties them together. Hit subscribe and smack that bell so you catch it the moment it drops. No fluff, just the stuff that actually gets you hired. Before you leave, complete one practical assignment. Create a document named IT Glossary. Add the following terms: help desk ticket, SLA CSAT endpoint, MDM MFA single, sign-on identity provider, client server, hypervisor, IP address, private IP, public IP binary, bit byte. For each term, write a definition in your own words. One real-world example. Why the term matters in IT. Save this document and continue adding new terms throughout the masterclass. By the end of the course, you'll have created your own IT dictionary that you can review before interviews, certification exams, and technical discussions. Remember, successful IT professionals don't just memorize terminology. They understand how the concepts connect and how to apply them to real-world technology. Thanks for watching Hired in IT, where we turn IT knowledge into career opportunities.